So, hello, good afternoon. Today we will be covering the learning objective 2 of engineering principle, which is to know how to perform engineering calculations. So in this session, we will be covering express numerical solutions to a degree of accuracy that is appropriate to the value being calculated, use of algebraic expressions, define moments of force and solve related problems using formula, define work, power, energy, and solve related problems using formula. So since this is a long unit, we will be covering this in two parts. So today we will be covering part 1. So this is again a part of this session, this learning objective, which is define friction and solve related problems using formula. Describe the relationship between temperature changes and changes in length, and define types of heat and solve related problems using formula. So, let's move on to the first one, which is to express numerical solutions to a degree of accuracy that is appropriate to the value being calculated. So let's first of all look into the definition of accuracy. So the degree of accuracy refers to the level of precision or number of significant figures that is used for to express a measurement, calculation, or experimental result. For example, sometimes we take value of 7.99 as 8, but that may not be always correct in advanced calculations. For example, when you are using it in something related to calculation related to space or setting up a satellite and all. So you have to ensure that you have a certain degree of accuracy and how well a value reflects the true value of the quantity being measured or calculated. So these are the 4 points that you need to keep in mind when understanding degree of accuracy. So generally it is considered correct to 3 significant figures or 2 decimal places. So when it is correct to 3 significant figures, you express a decimal fraction in standard form, or you express tolerance in terms of size and limit. So these are some of the characteristics that you need to keep in mind when you are working on degree of accuracy. So we will look into examples of each of these kinds. So first one is correct to 3 significant figures. So when expressing a numerical value to 3 significant figures, we keep the first 3 non-zero digits from the left or use zeros as placeholders if necessary. For example, the result of the calculation is 25.45321. So the correct to 3 significant figures is 25.5. So we first 3 non-zero digits from the left. So you have 25.5. So that is how you use the expressing a numerical value to 3 significant figures. So next is like when expressing a numerical value to 2 decimal places. So we use an approximation to keep the 2 digits after decimal point and round the third digit if necessary. So for example, the result of a measurement is 13.98765. So it can be approximated to 13.99, which is correct to 2 decimal places. So now expressing decimal fraction in standard form. So the example is standard form is also known as scientific notation. So this is used to express very large or very small numbers in a concise manner using powers of 10. For example, the number 0.0000523 can be expressed in standard form as 5.23 into 10 to the power minus 5. That is how you can express 0.4 times 0, 523 in the scientific notation. Now next is expressing tolerance in terms of limits of size. So tolerance is the allowable variation or range around a specific dimension in engineering or manufacturing. It is expressed as a limit that ensures the part or product remains within acceptable standards. So it is generally used in, say, quality control calculations. For example, a cylindrical part with a diameter of 25 mm has a tolerance of plus or minus 0.02 mm. So the tolerance, the maximum tolerance permitted is 25.02 mm and the minimum is 24.98. So that is the range of the tolerance. So that is how you express tolerance in terms of limits of size or the acceptable standards. So next one is use of algebraic expressions. So algebraic expressions involves variables, numbers, and mathematical operations to represent quantities and relationships. So basically, this is used for algebraic equations, mathematical calculations, and it is a very, very important part of higher and advanced mathematics. And of course, it is used in engineering. So, for example, x is equal to a plus b, y is equal to c minus d. So, this is how you express the relationship and the quantities and the relationship. So, first, now we look into an example where we can use algebraic expressions to represent numerical quantities using symbols and apply the laws of precedence, which is normally called BODMAS, which is brackets of division, multiplication, addition, and subtraction to demonstrate the order of operations. So this is the generally acceptable the series or the hierarchy this is which is followed when using the algebraic equation. First comes the brackets, then comes the orders or exponents, then the third one is the division, the fourth one is the multiplication, fifth is the addition, and sixth is the subtraction. So this is the hierarchy that needs to be followed. You should always remember when you are doing mathematical calculations involving equations. So when you see an equation in this form, for example, solve for x where x equal to 36 divided by 6 into 3 plus 2 square minus within brackets 3 plus 5. So here what you need to do is I'm just wondering whether it started recording or not. Okay, so now that's all good. We proceed to solve this equation. So remember, this is brackets, orders, division, multiplication, addition, subtraction. So the first thing you solve is within the brackets, which is 3 plus 5. So all these things remain the same. It becomes 3 plus 5 is 8. Then you have orders. So orders, which is this one, 2 square. So again, all of those remain the same as well. 8 remains the same. So you become 2 square is solved. Then you have division. So you have 36 by 6. So which becomes 6. So this one is calculated first. Then the resulting equation becomes 6 into 3 plus 4 minus 8. So then you have multiplication. So you have 6 into 3, which is 18. So it becomes 18 plus 4 minus 8. Then addition, 18 plus 4, 22 minus 8 is equal to 40. So this is how you solve using the principle of BODMAS. Always remember this: brackets of division, brackets order, division, multiplication, addition, and subtraction. So this is a rule to be followed when you see any equation of this form. So next we move into define moments of a force and solve related problems. So force is one of the essential units. So whenever you use engineering, so you should always remember what are the different formulas of force, where it is used, how it is used. So what is the principle of moments? So this is an engineering principle where the principle of moments, which is also known as law of moments or principle of balanced moments, it states that a body will be rotational equilibrium and the sum of the clockwise moments about any point must be equal to the sum of anti-clockwise moments about the same point. So in order to be in equilibrium, if the sum of the clockwise moments about any point is not the same as the sum of anti-clockwise moments about the same point, then the body will not be in rotational equilibrium. So how do we do? See, this is how it is done. Sum of clockwise moments is equal to sum of anti-clockwise moments. So mathematically, this is how it should be. So for torque, So torque is the product of force. So here we have the definition. The moment of force is also known as torque. So a positive torque is counterclockwise direction. Wait, let me just go. Yes, it is counterclockwise, whereas a negative torque is a clockwise direction. So force into distance, that is how you calculate the positive torque, and and based on the direction. So the moment of force, it is known as torque, which is a general and basic concept. And it is the measure of the rotational force applied to an object about a specific axis. So here, if you see, the axis is the vertical point where the distance arrow ends. So that is the axis. The dotted line is the axis. So torque depends on the magnitude of force applied and the distance from the axis of rotation, which is F into D, and the angle between the force vector and the line connected to the rotation to the point of application of the force. So this is force into the distance, and then the angle between the force vector. So here it is 90 degree. So that is how you calculate torque. So mathematically, so all these formulas you should remember in mind. These will come in handy when you are doing assignments and mathematical calculations. So mathematically, torque is equal to force into perpendicular distance into cos theta, where T is the torque symbol measured in Newton meters. Force is the magnitude of applied force measured in newtons. Uh, Perpendicular distance, which is the R, is the shortest distance measured between the point of rotation and the line of action of force. So this is measured in meters, which is the standard units, which we have discussed in the previous class. And then theta is the angle between the force vector and the line connecting the point of rotation to the point of application of the force. So that is the formula for torque. So this is a formula you should remember again when you're doing the calculations related to engineering problems. Now, what is couple? Couple is another concept. So basically, a couple is a specific configuration of forces acting on a rigid body that produces pure rotation without any translational motion, which is there is no linear motion, it's only rotation. So a couple consists of equal and opposite forces, also called a force couple, and acting on the body at different points but along parallel lines of action. So that is how a couple works. So here let us consider an example. A wrench is used to apply a force of say 50 newtons to turn a bolt. So a force of 50 newtons is required to turn a bolt. So the bolt is 1 meters from the center of rotation, and the angle between the force and the line connecting to the bolt to the center of rotation is 30 degrees. So you have to calculate the moment of force applied to the bolt. So this is the scenario for your mathematical calculation. So again, we'll go through it. So a wrench is used to apply a force of 50 Newton to turn a bolt. The bolt is 0.1 meters from the center of rotation, and the angle between the force and line connecting the bolt to the center of rotation is 30 degrees. So you have to calculate the moment of force applied to the bolt. So here we have the data which is given is force F is equal to 50 newtons. So this is already given. If you go back here, you see it is given force is 15 newtons. Then perpendicular distance is 0.1 meter. So here you have 0.1 meter. Angle is 30 degrees. So here again it is given 30 degrees. So first convert the angle from degrees to radians, which is a fundamental calculation. So it is 30 by 180 into pi. Pi is 3.14 is equal to when you get this calculation done, it comes to 0.5236 radians. So now when we use the moment formula to calculate the torque, moment is equal to 50 into 0.1 into cos 0.5236, which is the radians. or you can also use cos theta in terms of degrees, which is cos 30. Then so it becomes 50 into 0.1 into 0.866, and moment torque is equal to 4.33 Newton meter. So the moment of the force applied to the bolt is approximately 4.33 Newton meter. So this is how we have got the calculation. So so let's once again we go through the so you have a force of 50 newtons is used to turn a bolt. The bolt is 0.1 meters, and the force and the line connecting the bolt to the center of rotation is 30 degrees. So you have to calculate the moment of force. So what we do, we write down whatever is given to us. This is a standard format of solving any engineering problem. First of all, you write down the given data, what is provided to you. Then you can then work out on the conversions. So for example, theta in radians is equal to this, and then you have moment torque is equal to 50 into 0.1 into so and so. The moment of force applied to the bolt is approximately 4.33 Newton meter. So this is how you get the torque for the problem. So here we have extended sessions. So probably today we will end it here, and then next week probably we can have 2 back-to-back sessions so that we can complete it full, because this is one lengthy session. So hope that works out for you, Ayan.